everyone, I am Sneha from the Web3 Compass, and this is day 11 of 30 days of building with Solidity. For everyone who is aware about what this campaign is, you know what I'm going to do next. And for those who have stumbled upon this video randomly, please go to my day 1 video. That is where I talk about the entire program in detail. Or you can head over to web3compass.xyz and check everything yourself. Now, before we head on to the actual implementation and talk about that what is it that we're going to learn today, I understand that things might get a little overwhelming, concepts are getting tougher. And then from one contract, we've moved on to writing 2 contracts, right, in terms of implementation. So if there are any days where you feel like, oh my God, this is just getting out of, out of my brain, I'm not able to understand this, I don't have the motivation to do it, just take a break and then get back to it, because trust me, all of the work, all of the things that you're learning, that hard work really, really adds up and gives you some amazing results. That is what I have believed all these years, and then it has always helped me in some or the other way. That was a little pep talk, but let's just head to day 11. So today we're going to write a smart contract called MasterKey.sol. It is actually 2 contracts that we're going to write. In the concepts that you will master, you'll talk about ownable pattern, inheritance, robust access control. And as an example application, we say that, hey, build a secure vault contract that only the owner, which is the master key holder, can control. You will split your logic into 2 parts, a reusable ownable base contract and a vault master contract that inherits from it. Only the owner can withdraw funds or transfer ownership. We have previously implemented such functions already, but we will see that how we're doing it through a concept called inheritance, and I'll talk about the concept in more detail. This shows how to use Solidity's inheritance model to write clean, reusable access control patterns, just like how you would do in real world production contracts. That's it. So let's just head over to Remix. Now, before, people who have been with us for the past 10 days, you know that we were initially writing just 1 smart contract and everything was packed into a single file doing its own thing. In day 9, we wrote 2 contracts in which we saw that how are contracts communicating in between each other. We saw it through a direct call, how we are importing it, performing an external call. We also said that we'll talk about delegate calls later. And now we'll see that how you can make all of that reusable, like certain features, okay? So as the contracts get more complex, you will start to notice the repetition where you would be like, hey, didn't I already write this ownership logic somewhere else? Hey, why am I copying the only owner check again? Like the same modifier again and again, right? So that is where Solidity gives you something very powerful called inheritance. Now, inheritance is not a new concept that you will see just in Solidity, but it has been there in other programming languages in Web2 world as well. So all of you who are coming from a tech background, you might just know about it. For those who aren't, let me just explain it to you in layman terms. Like, let's say your parents own a house and one day they pass it down to you. Everyone wants that, right? Now, when you inherit that house, you're not just getting the 4 walls, you're getting everything that comes with it. The furniture, the rules like no shoes inside the house, maybe even the family dog. I hate dogs, by the way. So you didn't set up that yourself, right? But you still have access to all of it. That's exactly what inheritance is like in Solidity. You will have 1 contract called the parent contract, which defines a bunch of logic, functions, variables, modifiers, etc. And another contract, the child, which inherits it all. You can use it as it is or modify part of it suiting its needs. For example, if you don't really like the sofa in the house that your parents have given to you, you can add a recliner, right? You don't necessarily have to use that sofa, right? So you can always do that modification. Now, why should we use inheritance? So it helps you avoid writing the same logic in multiple places, split your code into smaller focused pieces, reuse important features like access control or utility functions. Like we've talked about transfer ownership or modifier thing. You've seen a few contracts where we've been writing the same thing again and again. So you can just reuse all of it and make your contracts easier to update and maintain. For example, if the transfer ownership or only owner modifier needs update, right? You can just go update it in the parent contract. And then since all the child contracts are inheriting that, they will automatically reflect those changes rather than having to change it everywhere, everywhere that you're using it. So now now we've talked about, okay, how are we going to change something like that? But these changes do not just come like, hey, you know what, I want to implement these changes, let's go about it. So if you get all the functions from the parent contract, but if you want to change how one of these function behaves in a new contract, Solidity gives you a very safe way to do that using two keywords, which we will look into in the coming section. First is virtual, which goes in the parent contract. It makes a function changeable. It's like the parent saying, hey, here's the rule, but feel free to change it if you need to. And then override goes in the child contract. It tells Solidity that I know this function was inherited, but I'm replacing it with my own version. Okay. So you must use both. Otherwise it will throw an error, and Solidity won't accidentally, override something unless the parent has explicitly allowed it. Okay. So this keeps your contract clean, predictable, and easier to maintain. You know exactly what's inherited and what's been changed. No surprises. And in short, inheritance gives you everything from the parent, but with virtual and override, you get the flexibility to customize just the parts you need. This way, Solidity keeps things safe and clear, no silent overrides, no accidental changes. Everything's just intentional, okay? Now, coming to what we're building today, you're going to write two contracts. One is Ownable.sol, which is a simple contract that defines who the owner is and gives you a reusable only owner check to protect sensitive functions or the functions where you would want only the owner to perform a set of actions. And the other one would be VaultMaster.sol. So a vault that accepts ETH deposits from anyone, but only lets the owner withdraw. Okay. Instead of writing the ownership logic again in that vault contract, it will simply inherit from Ownable. And so let's just get started, right? There's a lot more that we're going to talk about. We'll see some example contracts. We'll also talk something about OpenZeppelin, but then it's towards the end. So let's just get started. I will quickly create two files, Ownable.sol, and then other would be VaultMaster.sol. Okay, great. So now, just quickly copy this, Ownable.sol. Fine. So now, contract Ownable. We know that this is going to be the parent contract, which is just going to implement all the logic. Now, this contract will be very, very simple because we're just going to talk about certain ownership things in writing modifiers and also use events and emit so that we can practice the previous concepts. For those who don't know what event emit is, you can go to the previous day video. That is where we talk about in detail and we say, hey, you know what, let's just get started. So AI suggests address private owner. Great. We would want an owner and we'll declare it with the address data type. I don't want to use underscore here because we have been using it as a different naming convention. And we know that, we're going to talk about, okay, let's just remove this. We've always talked about how we would want to declare variables first, move to constructor, also talk about modifiers, and then write functions. But then also now that events and emits are introduced, we know that events also need to be declared, right? So we say, okay, let's just write constructor first. So we'll say constructor owner equals to message.sender. This is what we've done everywhere previously, wherever we have used and owner section. Then we say, hey, modifier, only owner, and we say, okay, great. So we say require message.sender equals to owner. If this is there, great. Otherwise, we say only owner can perform this action. Okay. So yeah, this is pretty simple. This is what we want to write. Okay, we're missing an underscore here. Great. So this is pretty simple, right? Now we're saying that, hey, if we talk about writing functions, we would want to say, hey, okay, so we're saying that maybe let's just quickly write a function that would just show us the owner address, like not very necessary, but we have to write something in this Ownable.sol. So yeah, let's just go about implementing it. We say, okay, public view returns address and then return owner. Okay, this is very simple. I hope everyone has already done it. You don't need to see my code here. Now, I would want to implement something as function transfer ownership. Okay, so now that I'm thinking about this function, maybe because this is one action that I'm trying to do here, which can be logged as an event, right? That right now I'm the owner and I make someone else the owner. So that could come as an event. I will just quickly declare an event here which says event ownership transferred. And what is it that we need? We need address, indexed. Again, we are using indexed for to be able to search it according to an index rather than to have to go through an entire list. So if you want to know about it in detail, go to the previous video. Now we say, okay, this is the previous owner. This will be, then I would say, okay, address, indexed, new owner. Okay, new owner. Great. So this is an event. So we'll have to write an emit here, but let's just write the function first. Function transfer ownership. Oops. Transfer owner. Oh God. Just one session where I can not do any typing mistakes. Okay. So now for transfer ownership, obviously you will have to provide the address of who you want to be the new owner and also restrict this particular function to be only performed by a current owner, right? So we say address new owner. We don't need external here. We say, okay, let's close this and we say, okay, public new owner. Okay. Naming conventions, again, underscore works better for me here. So we say, oh God. Why is AI making my life difficult? Okay. Okay, great. Yeah. And what is it that we do here? So first we say, hey, let's check a condition if the new owner is not an address 0, right? New owner not equals to address 0. Great. If it is, then it's invalid address. Now, all of these line of code should be very, very predictable for you because we've implemented it like 8 times already. And then we say, hey, address previous equals to owner. Okay. And then owner will be the new owner, right? Now, why we're doing this is that when we transfer this, ownership, we should be able to see that who the previous owner was and who the current owner is, right? And then we say, okay, now it's time, the particular event has been done. So I'll say emit, ownership transferred, and then previous. No, we're using previous keyword, right? So that is why we'll say previous and then we'll say new owner. Great. That's it. That's our entire ownable contract that we're talking about. Everything's pretty simple. From the first address variable that we're talking about to writing an event to a constructor where we are declaring the message.sender as an owner to writing a modifier. There's nothing new that we've implemented here. And this is going to be a reusable contract that tracks the current owner and then restrict access to sensitive functions, allow ownerships to be transferred and emit events so that, when the ownership changes, they are logged publicly. And then if you're working with the front end, then you're able to see it. So we compile it. Everything's working fine. We don't need to deploy it at the moment. We'll just see the deployment all together. Let's go to the file. Let's go to VaultMaster.sol. But before that, let's just copy this and go here. This remains the same. Now, two things. We will first import Ownable.sol. Everybody should, who has watched day 9 video, day 10 video, you should know how I have imported a contract previously. It has to be in the same directory as your current contract, and this is how we do it. We use the import keyword and then we provide the name of the contract. Okay. And then we say, okay, contract, we want to name it VaultMaster, and then we say is ownable. So this is a sign of inheritance coming into play. Okay. We're saying that once we've imported this, like there is another file called Ownable.sol, you're importing it. So now everything that is defined in Ownable, including the only owner modifier, transfer ownership, needs to be available in a VaultMaster. And then when we say contract, VaultMaster is ownable, this is the key line which says, hey, VaultMaster inherits from ownable. Okay. So now it automatically has all the functions, variables and modifier from ownable. Okay. So now with Vault, what we want to do is we want to go about depositing ETH and withdrawing it. Okay, very simple. Maybe write a utility function that helps us get balance of it. So that's it. That's all we'll do. And you've done this before. That is why we want to keep it really simple and quick. That how are we implementing that entire thing? So now that we know that, hey, you know what, we want to deploy, we want to write functions where we're saying deposit successful and withdraw functions. We want to write events around it. Now you don't need a variable here because we've already declared an owner of the vault. We are not getting into how many people can join. Why would people join a vault, right? If it would have been an application and if you have not declared a variable in ownable contract, then you might have to just implement it here. But here we do not need to add any variables. Only if you're looking at modifications, you might want to add it. So let's just go about writing two events that we can think of. Event deposit successful, and we say, okay, address, okay, which account is actually using that or depositing to, and then uint 256 value. Okay, how much is it that we have deposited, right? And then we say event withdrawal successful, again, index account and not account, the recipient, okay, who has received it or who is the person who's going to receive it. So that's it. Okay. Now let's just get to writing the deposit function again. AI suggests constructor public set owner message.sender. No, we don't have to do it because we've already implemented it in Ownable. And once we deploy it, I'll show you how both are interconnected and implemented together. So I'll say, hey, function. Come on, this is easy. Okay. Deposit. And then you don't have to you want that anybody can deposit in the vault. Okay. There is an owner of the vault who would come into picture when they want to withdraw, but then you don't want ownership on the deposit section. Okay. Anybody can just, withdraw it. Maybe have a vault where everybody deposits, but only the owner helps to withdraw. Now you can put conditions around who can deposit here as well, but it's fine. We want to do it quick because we've already covered those concepts where we are building an application where there's a registration process happening. Only certain registered people can do deposit, withdraw, etc. So we don't want to get into nitty-gritties of it. If you want to know how that is done, you can go to piggybank.sol contract or maybe activity tracker, simple IOU app. These are all day maybe 7, 8, 9. Now I've lost count of whatever I've taught on what day. So yeah. Now because we are going to deal with Ether way, we'll make this payable. Okay. And then we say, hey, you know what? Let's just check that the message.value, again, I just hope that everyone knows what message.value is here. If not, again, go to the previous videos. It has to be greater than 0. If yes, great. Otherwise, you have to enter a valid amount. And, okay. So you enter a valid amount and then that's it, right? Now you just have to provide the amount of Ether way that you want to send and it's done, right? So the event needs to be triggered and it says emit deposit successful message.sender message.value. Again, message.sender is a global variable that will take the address of the person who's performing this action, and message.value is the value that you've given for, depositing. Okay. So great. Very cute little function. Here it is. Then I want to write maybe function, withdraw. And we say, hey, now that we have to withdraw, we want a address where we'll withdraw, right? Or who we will send to. So address to, and then we say you went 256 amount. Okay. Now again, public, only owner. Okay. Now we don't have to make this, we can also make this address payable right here. Or we'll see how we can do it later as well. So we say, okay, require the amount, okay, is less than equals to balance of message.sender, not enough balance, right? So whosoever is sending this, but instead I would want to quickly write another function which says, hey, you know what? Let me just quickly write a function here which says get balance, function get balance. Okay. And it says, okay, public view returns and returns what? The UNT 256. And again, a good way to return this is address and then using this dot balance. Okay. All built in stuff. So here, instead of writing this entire thing, I would say just call get balance with whosoever this account is. And then if it's less than equals to, great. Otherwise, it says insufficient. Insufficient. Oh, are you guys not able to see it? I heard. Insufficient balance. Okay. Great. Oh, okay. Again, underscore. Underscore is the naming convention here. Why does this show address this dot balance? first return. Oh, sorry. This should be uint 256. This gives out uint 256. So yeah. So this is the required condition that we've written. And now we'll use the dot call thing that we've been implementing since day 8, I think. So what we'll write? We'll write a Boolean thing here, and we say, hey, success. Now, all of this is already taught, and then you don't have to, you should not like rethink about it. Just, you should have practiced this enough that you don't have to worry that, oh my God, what is she going to write again, right? And like I was saying, that this to address that we're talking about, we'll make payable. We'll make it payable here since we're dealing with money, and we'll say, hey, payable to, and that call. Now with this dot call, we have two arguments or parameters. I always get confused with these two terms. Okay. So we say value. Okay. Which is what? An amount, right? And then, not parenthesis, curly braces, guys. And then since we are dealing with an address, we'll just keep the encoding section empty, right? And then because we're using dot call, we say, hey, you know what? I really need to check if this call was made. And that is why we say require success. If yes, great. Otherwise, say transfer failed. Okay. And then now since we were withdrawing and the withdrawing is done, we say, hey, it's time that we emit an event. So we say withdraw successful and that _2_amount, right? So this is great. Like we're saying, hey, we have not even implemented only owner in this contract. Like, where is it? You know, such a small code. But then you're using only owner modifier here. But in the previous contracts, you used to write it. Exactly. That is the beauty of inheritance here. We didn't define it inside the contract, but we are inheriting it from the ownable contract. And, you know what only owner would do. It would check if the caller is the current owner and blocks anyone who from executing the function if it's not the owner. And then, great. I think that's good enough, right? So we just quickly compile it. Everything's working. Now again, two contracts here that we're looking at, Ownable.sol, VaultMaster.sol. So we will deploy this, went through, right? And then we say, okay, VaultMaster deploy. Great. So now you say owner address. This is my account address here. And that is the transfer ownership thing. And now here you're looking at, okay, deposit. So I'll say, hey, for the deposit thing, I would want to put in maybe whatever amount of weight, right? I deposit it and you can see, oh, okay. Now again, one way is 10 to the power minus 18 ETH. The other way around, 1 ETH is 10 to the power 18 ways. So that is why it's a smaller number. And then you get balance. You get the balance here. You check owner address. You get the owner address here. Now you can see that even though we have not implemented transfer ownership here, we are still able to get it, right? So we say, okay, address of the new owner. So maybe I would just want to quickly copy it and get it back here. And we say, okay, owner transact, right? So where is it? Like, where is the response here? So here you get it as new owner, and then you will see previous owner is this, new owner is here. Let's see how it would look like if we did it here, right? Great. So when we were looking at transfer ownership, you get all of these responses of what arguments we had and how is the new owner going to look like. This is the Ownable.sol and transfer ownership, right? And we're just emitting it as an event here. So you can check all of it, which was the first argument, which is the second argument that has been given. And yeah, the current contract address and all of it. So this is pretty much it. But that's not all, okay? There is something called as OpenZeppelin, which you will hear when you're dealing with probably ERC20. That is when it comes into picture. That is when I heard about it. So right now we have built this ownable contract from scratch, and that's a solid step in, learning how access control works, right? But in real world, developers don't write everything from scratch. Like, come on, you have built-in libraries. You would just want to use it, right? Instead of writing that code from scratch. So OpenZeppelin is a team of some amazing smart contract developers who have created a library of secure, reusable, and, community audited, very secure smart contracts for Ethereum. And their contracts can handle things like access control, which is again, ownable access control. They've created token standard contracts like ERC20, ERC721, ERC1155. Again, don't get overwhelmed. We'll talk about all of this in the coming days. They've also created contracts for security patterns, proxies, and upgradable contracts, and all of that. Okay. And these contracts are used across the Ethereum ecosystem by protocols, DAOs, NFTs. Because why? They have already been battle tested. They've been used in a real world application. So, and properly audited, free from, security attacks maybe, and all of that scenarios, and it's continuously maintained. It's a very trusted source. So if you wanted to, there is actually a GitHub link where okay. Can we just, I don't have So Ownable.sol, there's an OpenZeppelin section. They've written in Ownable.sol. We will add the link to this GitHub repo there. So what if we just want to import this instead of writing in Ownable.sol from our end, right? So I'll just go to Remix and I will show you how to do that. Okay, I'll zoom out a little bit. Come here. So yeah, we can just import the OpenZeppelin angle here, where I'll first comment this out and then say, hey, import OpenZeppelin, this and that. And then it says no arguments passed to the base constructor. Okay, great. Let's just look at it here. And it says, okay, so there's a constructor and address, right? So our constructor in the ownable one did not need a parameter. So we'll just have to quickly maybe write it like this. Constructor. Constructor and then ownable message dot sender. Okay, and we say functions without implementation cannot have address. Why? The OpenZeppelin section of, Ownable actually expects us to add a parameter past the initial owner when the contract is deployed. So I'm not sure why is this. Sorry. This should be like this. Yeah. And we don't have to go about this. Okay. Now, a few things, right? You are thinking, why is there an @ right? So this @ OpenZeppelin part is a shorthand used in Remix and in many other Solidity projects to refer to packages. What packages? From the NPM style package system. Even though we're not explicitly installing anything in Remix, it still recognizes and resolves this path behind the scenes. Think of it as OpenZeppelin ... So it's like, hey, can you grab this from the OpenZeppelin library package? And then contract / access / ownable.sol, the actual folder and the file path that is inside the package. So this line would be telling Remix, hey, you know what, pull the ownable.sol file from the contract / access directory inside the OpenZeppelin package, and Remix will automatically fetch the OpenZeppelin contracts when you reference them this way. Okay. Now, this is how it would look like when you are working with VaultMaster with the OpenZeppelin thing. Let me just deploy. So now this, you can look at, okay, yeah, ownable, and then, okay, this one cannot be deployed. Oh, yeah, it's like just importing it. And then you will see, okay, yeah, there's renounce ownership here in this code, right? Renounce ownership. So that is why you can see that function. So it's, yeah, it's just a quick way to check that everything's inherited. So you can explore around the what is it? How do you give the input here, and what is it that you're getting out of it? In the longer run, you'll have to write less code. You'll get fewer bugs because, again, OpenZeppelin it is, right? It's well audited. It has been used out there. A lot of dApps and advanced apps that you will see are using these standards, right? Now I can also quickly show you that, okay, let's forget about VaultMaster Ownable.sol. Can we just use this Ownable.sol in one of our previous codes, right? So let's go to tipjar.sol. I think this was what, day 9? Day 9 maybe, right? Or day 8. I forgot, right? So there is a modifier only owner, and then there was transfer ownership. So maybe let's just try importing it here and see what happens. I'll say, okay, import dot ownable.sol, right? Great. Now I will comment this particular section. I don't want to transfer ownership here, and I'll just let this modifier only owner be, right? Okay, it's repetitive. We've written it in ownable.sol. Okay, we've written this already. So you'll see what happens. Now let's just quickly close the previous ones and say, okay, ownable, let's deploy. And then we say tip jar, let's deploy, right? And you've gotten all the things here. But then you see, nothing happened, right? Why? Because we forgot one thing. How are we actually inheriting it? We didn't tell tipjar that, hey, this has to be is ownable. And that is where the real problem comes in. So because both of them had a modifier, if you look at the error clearly, it says overriding modifier is missing. Override specifier. Okay. So now it will talk about two of them. One is Ownable.sol and the other one is in tipjar.sol. So it says, okay, there's a modifier only owner here and there's a modifier only owner here, which is in tipjar, right? So if we use the override keyword, which we have talked about, that it should be there in the child contract, it will be gone. Okay. And then it says, hey, you are trying to override a non-virtual modifier. Did you forget to add virtual? Yes, we did, right? Ownable.sol is the parent contract that we're talking about. So we had to make it virtual, right? If we are doing repetitive things. And in VaultMaster, we did not do it. We did not bother to write a modifier for only owner in a VaultMaster. We just inherited it. But here, since we already had an implementation of tipjar.sol, you see, hey, you know, there's a repetition and we're missing a few keywords. So let's just come here and then say, okay, make this virtual. Okay. Now come here and whoosh, it's gone, right? It's gone. And I'll show you how the deployment looks like. So I say tipjar.sol, ownable.sol deploy. So now, even though there is no, oh, where is it? Okay. So here, if you see owner, okay, and you see owner address, great. Now, if I just copy this particular address, right, and then you say, hey, can you just transfer ownership? And you see here, and now if you get the owner, oh, we commented it here, right? But there was a transfer ownership here. So, wait. Can we just comment it and say, hey, what is it? Okay, so we are trying to override this as well. Okay, now Okay, this should be fine. Right? Or did I miss something? No. So we did not actually compile it. Let's just comment this and see what happens. Okay. So we're still looking at compiling tipjar.sol, and we're also looking at compiling this after making it, virtual. And then I say, hey, compile on it. Let's just remove this. And I say deploy, great. And then, and then deploy this, great. And now, okay. Yeah, okay. So I don't know why was I not able to see it, but what I was trying to tell you is that we did override here, right? This is tipjar.sol and Ownable was here, right? That was a repetitive thing. Now you can see the other implementation of inheritance here is that for Ownable.sol we have something called function transfer ownership, which we have commented here in the tipjar.sol. We could have just kept it and again used the same thing as override, virtual. But even though this is commented, because we're inheriting it from owner, you can see the transfer ownership here, right? So what I was trying to tell you is that Ownable.sol is not just for the VaultMaster contract. If you've written it, you can just use it anywhere, like with any of your upcoming contracts, right? So I think, yeah, that's it. As a recap, we've written a base contract that controls ownership, how to inherit the contract in another, how are we using modifier and events to control visibility, and then how are we using virtual and override, where should we use it, how to structure your Solidity projects more clearly, write cleaner code, and how to use OpenZeppelin's Ownable for real world use. Again, on the next day, we're going to write an ERC20 contract and we will do the implementation from scratch, but we will also look at OpenZeppelin's way of doing it. And yeah, I will see you for day 12. Keep building.